In a previous video in this series, we looked at addition and subtraction with base 5. We really focused on base 5 and what it means to add and subtract in a system that's not 10. And what we're doing now is we're shifting to any non-decimal positional system. Decimal relates to 10, so it's saying in any positional system or place value system that's not base 10. So here we've got base 5. I'm just going to do that as a reminder, but then we move on to base 6, base 3, base 16, and on it goes. So quick review with the base 5. Sometimes we write our digits to remind ourselves what we have to work with. And you might find that particularly helpful as we change back and forth from one base to another. We've also talked about having a little reference chart, which is okay to use when you're learning, but I'd rather you didn't write this on the test because I'm trying to move you towards thinking in terms of grouping. Once upon a time, you learned this, and I want you to be super proud of your 6 or 7-year-old self for learning how to work in base 10 because you had to understand all the symbolism. Granted, it was only one base, but that was just as new for you back when you were 7 years old as this is now. You did this once upon a time. I know you can do it now, so hang in there. On our little reference chart, I'm going to write in the numbers. But one thing I want to caution you about is that it may have been tempting in the last video to start trying to memorize. Oh, that 1, 3, the thing that looks like a 13, that's always an 8. The 1, 2, the thing that looks like a 12, that's always a 7. Well, sure, in base 5, but you might be asked to add or subtract in any base. And if you're working in base 16 or base 7, a 1, 2 is not a 7, it's something different. Okay, so try to move towards the grouping instead of leaning on the reference charts, but feel free to start with them. That's okay. So we're doing addition here. We start out with 2 plus 3, which equals 5. Well, a group of 5, we see it right here. It looks like a 10. So I carry a 1 and I have a 0 in the ones place. Then I have 1 plus 3 plus 4. That's a total of 8, which is a group of 5 plus 3 left over. So here's the 3 left over and we carry the 1. And again, we said 8 because we've been working in base 5. You guys are kind of used to that. A 1 and a 3 gives us an 8. But in different place values, that's going to be different. So over to the 25's place, 1 plus 4 plus 4, that's going to be 9, and a 9 is a 1, 4. And if you're starting to move towards what I've suggested, where you say, oh, there's a group of 5 that's moving, you might have been able to do that even more quickly by just dropping the leftover 4 down and carrying the group of 5. Either way, our answer is 1430, and that is in base 5. The same concept works for any base. We're in base 6 because it's new to us. I might want to write my digits. Now I can use 5 as a digit because I'm in base 6. So my digits stop 1 short of that, which is 5. And I might want to put, again, a little reference chart up here. And we can fill that in if we need to. I may just leave it as is for now. 2 plus 4 is 6. It's a group of 6. Go ahead and write that. That's a 6 with no ones. Looks like a 10, but it's a 6. 1 plus 1 plus 2, well, that's 4. That is not 6 or higher, so there's no carrying to be done. It's just a 4. And then 5 plus 4 is 9. Well, 9, that's a 6 plus 3 ones, right? We're working in base 6. 9 is one group of 6 plus 3 ones. So I have a 3 down here, and I carry the 1 over. And my answer is 1340 in base 6. And 9, if you wanted to write it up here, 9 is 6 plus 3, isn't it? Which is why I got that 1, 3 at the beginning of my answer. Remember, at any point, you can pause and just look at that for a while, or you can go back and rewatch it. Do whatever you need to comprehend this topic. So here we have base 3, not many digits at all. Total of 3 digits, 0, 1, 2. We have a 1's place, we have a 3's place. Right off the bat, I have to do some carrying. It's 2 plus 2, which is 4. But that's a group of 3, which is going to carry plus 1 left over. So I carry the group of 3 and leave a 1. Or I could look over here and say, well, 4 is 3 plus 1. It's one group of 3 plus 1 more. And you see that thing that looks like an 11, but it's not. Moving over to the next place, 1 plus 2 plus 1. Well, that is also 4, which leaves a 1 behind and carries a group of 3. 1 plus 0 plus 1 is 2. No need to carry because we haven't hit 3, so we're not in the next place. Oh, the last column is 1 plus 2, which is 3. That's a group of 3 with nothing extra. A number always looks like 10 in its own base. So in base 3, 3 looks like 10. And so our answer is 10211. If you had wanted to, you could have written a little reference chart. 10 is 3. It's not 5 like in our last video because we're in base 3 now. 11 is 4. 12 is 3 plus 2, it's 5. Your next number, by the way, if you kept counting, would be 20, which is 6. It's 2 groups of 3. Moving on to base 16. Trickier still. I am going to write out all of my digits here. I think it's going to be particularly helpful to us in this one. Oh, I almost wrote a 10, but these are digits. We don't have 2 things in one place. In base 16, after 9, we have an A standing for 10. 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. We can't write those as 1, 0, 1, 1 because in a positional system, we only have one symbol per place. We might also want to write our little place value. We have a 16's place and a 1's place. So if we ever get something that looks like a 10, that is actually a 16 because it's a group of 16 and no 1's. The next number up looks like 11, but it's 17, and on we could go with that. So in the 1's place, we have a 6 plus 4. That is 10. But how do I write a 10? That's a 10. It's A. I don't keep a 0 and carry a 1. That would be a 16. 6 plus 4 is not 16. It's 10. And 10 is written as an A. In the next spot, we have 4 plus 0. Fantastic. 4 plus 0 is 4, and that's easy enough to represent. I see a 4 sitting right there. B plus 2. B is 11, plus 2 more gives us 13. Which of those symbols up there represents a 13? Or you could just count it off. Here's B, plus 1 plus 2. That's going to be D. So our answer is D4A. Base 16 can be pretty hard on us because once we get higher than base 10, we're using letters, and it can be especially easy to get mixed up between what looks like a 10 but equals 16 and what the value of 10 really is, or what the symbol for 10 really is, which is an A. So if you need to pause here or go back a little bit and rewatch this one, that would not be a bad idea. That would be quite a good idea. And we are going to stick with base 16. I want to do 2 base 16s in a row, but this one is subtraction. At any point, of course, if you want to pause and try it on your own first and then check your answer against mine, not a bad idea. I am once again going to write out the digits. I'll do it down here this time. It's good practice anyway. When I hit that 9, I'm so ready to write what looks to me like a 10, a 1-0. But in base 16, a 10 is an A. Okay, and I might want to just make a little place value chart here so I can think about things and check them out. So in the ones place, we have B minus 1. 1 is smaller than B. I don't need to do any borrowing here. This is fine. B is 11. 11 minus 1 is 10. And how do we write a 10? Right? It was B minus 1 is A. Or 11 minus 1 is 10. Then we move over to the next place, and I have 1 minus 2. Well, we need to borrow, right? I go next door to 0. I've been hitting you really hard with these zeros. Go all the way over, borrow 1 from the 9. You're going to carry, maybe carry is a bad word, regroup is maybe another word. You're going to take one group of 10 from that number and give 10 to the next. But be careful, this number 10, that's not the same thing as A. 10 is a 16. Now we still need to borrow from that because we were trying to do the 1 minus 2 and we couldn't do it. When I borrow from 10, it's not 9. It's really tempting to cross out something that looks like a 10 and put a 9, but it's not. A 10 is a 16. 16 minus 1 is 15, and that is right here. That's F. I know this is really weird and really hard at first, but once you do quite a few of these, it actually does come pretty naturally. That's why you've got to allow your mind to think in terms of grouping instead of always wanting to have a cheat sheet to look at, or don't say cheat sheet, say reference chart. If you think in terms of grouping, it's going to move you along faster and help you. Okay, so I did the borrow, but I didn't give that value to the next number over. So I crossed out the 10, the 16, decreased the value by 1, which gave me the F for 15, and now I carry a 1 next door. Looks like it's an 11, but we're in a 16 place value system. 1, 1 is a group of 16 plus 1 more, which is 17. I have 17 minus 2. You know what 17 minus 2 is? It's 15. But do you know how to write it? 17 minus 2 is 15. 15 is written as F. That's our digit for 15. Ooh, that next one, that's interesting. I've got all letters there. I have F minus A. Well, F is 15 and A is 10. What's 15 minus 10? Isn't it 5? And then 8 minus 3 is also 5. Continuing with subtraction. Let's drop to a much lower base. We have base 3. So our only digits are 0, 1, 2. And our place value is a 1's place and a 3's place. Here I will have to borrow right away because I can't take 2 away from 0. So I borrow, and that's what it looks like. That is not 10 minus 2. If I thought this was 10 minus 2, I'd write an 8, but look over here. I don't have something that looks like an 8. I've only got 0, 1, 2. That thing that looks like a 10 is a 3. 3 minus 2 is 1. Oh, I'm going to have to borrow again. And I get 3 minus 2 again. Oh, and then 1 minus 1 is 0. But I wouldn't write a 0 if it's the first digit in my number. So this is 1, 1, base 3. That's our answer. And I am kind of speeding up on these a little bit as I go because you've seen quite a few examples. And I don't want to always be talking so much that you kind of lose the momentum and you lose track of what we're doing. So here's base 7, and I'm going to just move through this one. Just going to move through it. I will put this up here as a reference without making the whole chart. And remember that the digits you have are 0 through 6. 4 minus 1 is 3. 3 minus 6, can't take bigger from smaller, so I borrow. 1, 3 in base 7 is 10. 10 minus 6 is 4. 5 minus 5 is 0. 5 minus 2 is 3. That's the answer. We're done. And I will go back a minute and talk about the part that I think was the hardest. I just very quickly said a 1 and a 3 is 10. Because that's one group of 7 plus 3 more. And 7 plus 3 is 10. And then 10 minus 6 is 4. So that's where that came from. Then we have a problem at base 2. Base 2 is almost as tricky, maybe it's trickier, than base 16. Because you only have 2 digits, 0s and 1s, it almost feels like you can't, there's nothing to grab onto, there's hardly anything there. But here we go. In the 1's place, 1 minus 0 is 1. I don't care what base you're in, 1 minus 0 is 1. But in the 2's place, we have 0 minus 1. We can't do that because 1 is bigger than 0. Oh, now I have 1/0 minus 1. Well, a 1/0 is 2. This is 2 minus 1, which is 1. Because this is kind of a hard base to work in, I'll write it up there. The thing that looks like a 10 is a 2 because it's one group of 2 and no 1s. I need to borrow again. And we have the same thing all over again. So there's our result. We've got one in base 4 here. Did I do any more? Nope, that's going to be our last one. But remember, as you're working in the My Math Lab homework, they do have the Help Me button up in the top right, and you can have them show you a similar problem, or you can have them actually help you work through the problem that you were given and then give you a similar problem to solve. So don't forget that as well as the videos I've provided, you've also got the help in My Math Lab. Base 4, let's remember that we are restricted to digits 0, 1, 2, 3. But our place value is a 4's place and a 1's place. Okay. 3 minus 2, that's all good. I'm not taking a bigger number from a smaller one. 3 minus 2 is just 1. Over to the 4's place, I can't take 2 away from 1, so I have to borrow. I get 1, 1, which is 5. 5 minus 2 is 3. 2 minus 1 is 1. And there's our answer. And one more time, I'll just do a quick revisit. Why is it that this thing that looks like an 11 is a 5? Well, is it because it's one group of 4 plus one more and 4 plus 1. is in fact 5. So I hope this video and the others I've provided have been helpful to you in learning to count in different bases, convert from and to different bases, and add and subtract in different bases.